6271. It's 800-519-6271.
Or at SwissAmerica.com.
His hair was falling out in clumps.
Our golden retriever, Sundance, he scratched incessantly.
Mounds and mounds of fur all over the place.
Our hairballs have hairballs.
Olive was suffering like a dog. She was itching, she was scratching, she was licking 24 hours a day.
Just chewing and chewing and chewing.
Scratching and biting.
Buddy, my Shih Tzu's itching problem, constantly licking his feet. It keeps me up at night.
And all it took was one container of Dinovite.
DINOVITE.com.
859-428-1000.
The omega-3 fatty acids.
Flaxseed, zinc, alfalfa.
The digestive enzymes that are cooked out of regular dog food.
The shedding slowed down to almost none. The scratching went away after a few days.
Tons of energy, no more bad smells.
The shedding has stopped and the itching has stopped.
Sleep at night. Let me do it again. Sleep at night. Get your dog some Dinovite.
859-428-1000.
859-428-1000.
DINOVITE.com.
New England Real Estate Journal Radio.
And we're back on New England Real Estate Journal Radio. I'm Rick Kaplan with Eric Wilson, and we're talking with Jeff Fullerton. He is a principal consultant in acoustics for Ascentec. And before we went to the break, you were talking a little bit about some of the projects that you were working on. What type of companies actually use your service, like architects, engineers?
So our primary clientele are the architects and engineers who are designing new spaces. And they bring us on either because they have past experience with acoustics or past experience with us, or possibly the client has suggested that there are some acoustical issues that need to be solved. So that's primarily who we work for, although we do a lot of work also for owners, and those owners might be a university or it might be a corporation that needs us to come in and look at a specific element of their operation that needs some noise control.
Now, I have a question on, you were talking about earlier about mills, these old mills that they're converting now to office space as well as multifamily. Yeah, how do you go in after the fact? You know, these have been up for many years, and now you have to change the sound, because a lot of them used to be very echoey.
Yeah, well, and they're classic big open spaces, usually made with timber floors, and the historic aspects of them are often attractive to leave exposed. The idea of having this timber beam ceiling is often very attractive to residences. Yeah. The challenge is people also like hardwood floors, and so there's an idea that, well, we'd like to just sort of clean everything up, put some walls up, make some residences, but those mill buildings were never intended to provide isolation, particularly when you have two spaces stacked above each other. And so we find that to accomplish the code requirements for multifamily buildings, but also just the expectations of the residents, we often have to introduce flooring materials that introduce mass and some isolation. And that way you can block the sound of voices, TVs, but also reduce the footfall impacts that you would otherwise hear. So it's working with the architect through the design process to say, you know what, that timber floor is a great structure. It's going to support a lot of weight, which it has done for years, maybe hundreds of years, but it's so strong and so stiff, it's also going to transfer sound very well. Or in one case, you could actually look through the timber beams to below. Not a good situation. So whether it's the flooring materials on top, which is often attractive because then you can leave the underside exposed, which residents like, or some sort of ceiling below, leaving the floors exposed. Those are two approaches.
So you would have to put some kind of covering on either the top or the bottom of that flooring.
Yep.
You couldn't leave it exposed on both sides.
No, it's doing that, you essentially allow for the sound of footfalls to be clearly heard downstairs, and it would wake people up. It would bother people when they're trying to talk, watch TV, and do
because so many
activities.
times you'll go into that type of a structure that they're working on, and you see they do keep them exposed.
Yeah.
I was just kind of curious on how if they keep them exposed, then they can't really have to worry about how the sound is being transferred in that property.
those are the projects we get called in after the fact.
When the residents start complaining, I can hear my neighbor constantly.
Exactly. And yet we've also done some neat projects where we've dropped a ceiling below the beams in the lower unit and covered it back up with rough sawn wood, and it looks like the original deck, but you've got a great sound isolating construction that doesn't allow you to hear the transmission.
Well, I was just wondering what if they just tore up the flooring and put some kind of a sound, something to absorb the sound, and then put the flooring back down?
I'm sure there are contractors who might elaborate on that, but I suspect the cost of tearing it up and putting it back down, and also the condition of some of these floors is not very attractive. So oftentimes we're putting the sound isolating materials on the floors because we have to cover it up and start fresh.
But now a lot of them also brick.
Yes.
So you have a lot of brick wall.
Yep.
So how do you work with brick?
Sure. So one of the things with brick...
Stack them. Oh, sorry.
So one of the things with brick is often that if it's used for the exterior wall, it needs some sort of covering of insulation because for thermal reasons you don't want the brick exposed. So oftentimes that gets covered up. But there are projects where it's left exposed. And the biggest challenge with brick is actually how do you have a wall end at a brick wall and seal that up? Because the brick has all those different edges of grout and mortar and the brick face, and a wall needs to seal tightly to that to prevent sound from going between two spaces. So that's often the biggest challenge, is just making sure the contractor knows he needs a lot of tubes of caulk and a guy just caulking for days upon days.
So now what kind of material would you put on that?
Over the brick, typically for thermal insulation, they might do a stud construction with a drywall surface. And for acoustics, that can work just fine. For an exposed brick with a wall ending at it, it's just a sealant, a silicone sealant that can move with the constructions over time and make sure that it's just an airtight gap or seal.
What about these old buildings, the wind? You know, you hear howling wind come through walls all the time. Is that something that you have to be prepared for when you first build it? Like, okay, what's going to leak? What the window might not be fully sealed? And there's all sorts of different things when it comes to that.
Yeah, so we don't often get called in for wind noise issues, but one of the things with the exterior of a building is related to the outdoor conditions. And a great example of work we do for keeping out outdoor noise is either around the commuter rail, around Logan, around highways, all of those things. With the density of population, we're building closer to these louder sources. And, gosh, we've got a lot of developments going right up against the commuter rail line. And it's a pretty loud train that goes by a number of times.
Another reason for space travel, densing the population. I have a question. Are you... So the soundproof on the highways, we see those being constructed right now on 95. They're slapping those things in there. How efficient are those for the people behind it?
Well, the intent of that barrier is to reduce sound by somewhere between 5 to 10 decibels. And most people would perceive a change like that of being 20 to 50% of a reduction. So it's a fairly good reduction for the immediate neighbors. Once you start getting further away, the sky, the wind, and all the other meteorological things can reduce that number. But it's for those immediate neighbors that the benefit is for.
Right. Okay.
So
it is good, obviously, 50% noise reduction.
So how do you get an actual reading on the decibels,
on noise?
On the different noise levels?
So we have a room full of equipment that we can measure things with, and it ranges from handheld sound level meters that'll tell us to the 10th of a dB how loud sound is. We might measure for the barriers on one side of the wall, then measure on the other and look at the difference to determine that. With barriers, it's interesting because you often don't necessarily want to measure just at the ground location, but you might want to measure higher up in the air to see how much the reduction is at different heights of the barrier. But yeah, there's plenty of equipment these days.
But now, so when you go to do that, do you bring a whole crew of people to make a lot of noise, or you bring some instruments that bang, you know?
It often depends. If it's a highway, usually the highway's just going. And for other transportation sources, you might just wait for the plane to fly over or the train to go by. But we also, along with equipment that measures sound, we also have a lot of loudspeakers that produce a lot of sound. So we can't necessarily produce a concert, but we've got some really loud sound equipment.
Well, and speaking of that, you also do audio and video equipment.
We do, and one example is for the MFA, we helped design the sound system at the Museum of Fine Arts.
Hey, thanks for breaking that down for Rick.
We helped integrate a sound system that could direct the sound to the listeners on the floor rather than just send the sound into the whole space. And by doing that, we were focusing the sound where it wanted to be instead of just sending it out into the room where it could reflect around too long.
Right.
But my colleagues who work on what we call systems, or information technology systems, they do everything from airport communication systems to boardrooms to a wide range of athletic facilities and the sound systems for those, and even performing arts centers and the sound systems that go into those. And it's amazing the way in which the information technology and the audio systems have melded together these days so that much of this is so easy to create in a digital format. And it's a lot of what we're doing is creating the pathways of infrastructure and the connections of the equipment, and then all of that just goes onto a digital backbone that relays it around.
So when you're putting in the equipment, being in the acoustic arena,
Spit it out.
Yep.
You know, that you have that can help with the sound quality of the audio equipment that they're putting in.
It can, and so oftentimes our group who works on the systems and us in the architectural side will talk to really make sure that the equipment they're selecting is appropriate for the application. If we've got an atrium, we don't want to just broadcast the sound everywhere in the atrium. We'd really like to put it where it needs to go for people to hear it.
That's a good point. You can direct the sound to fit to a certain area?
There's more and more speaker systems that allow you to basically put the sound where it needs to be heard rather than just broadcast it into the whole volume of the space. The way we've done for so many years up until probably about 10 years ago, these systems really became more popular. So we can aim the sound toward the audience rather than just have it liven up the room. And when you fill a room with sound from a sound system, oftentimes that makes it less intelligible and less clear. So that can be a problem that even though you make it loud as could be, you still don't understand it, even if it's louder.
Yeah.
So the intent of the design is really to make the clarity and the intelligibility of the system.
How did you get into the acoustic field yourself?
So myself, I was a mechanical engineer by education, and at the same time I worked backstage in a performing arts center on campus, which happened to be designed by the company I work for. And actually the very recent exciting part of this was I melded those two things together to essentially enter my career here at Ascentech. But we actually just won a contract to go back to that Performing Arts Center and improve it, because right now it's really designed like Symphony Hall, but they use it for lectures and all sorts of other things where the clarity isn't there. So we're actually excited to be working on that and improving it. So,
nice. Look at that. Brought you full circle all
That's
in
right.
one question.
So, Jeff, if someone is interested in having someone come down and look at their property or are interested in putting together a property that they have acoustical problems or eliminate the problem, how would they get a hold of you?
Well, people can reach us through our website, acentech.com, ACENTECH.com. We often, again, work for architects and engineers. We do some work for residences, but our rates are not necessarily geared for a residential consumer market. But people should reach out to us because we're always curious to
any
see
of those
if we can
people
help.
that are buying those $1 million+ homes, they could use
Especially
your service.
before the Super Bowl, so we can
That's right.
aim it all right to your couch, so you
That's
don't have
right.
to move. You can just hear everything to
You
you.
can hear all the footballs being
All the footballs being inflated before halftime. I just had to throw that out there. Big Patriots fan, yeah. Big Patriots fan.
Well, we appreciate you coming on the show, Jeff.
Definitely. Thank you, Jeff.
Thank you very much for having me.
And we're going to go to a break. When we come back, we're going to
wrap up.
Have a little